Welcome everyone. In today's session, we will continue from the previous session and give you a brief idea or the overview of the Unix operating system. So, in the prior class, you all had some issues to regarding understanding the Unix system. So, sir asked me to give you a brief overview so that you guys can uh, follow along with us. So, let us start. Okay. So, Unix is basically a foundational operating system that was built in the early 60s, and then Linux came along that gave the users a better user interface, which was actually a cherry on the top of our cake for us as users, right? So, Unix is the underhood term that has similar operating system all across. For example, we can take Linux, Ubuntu, Mac OS, and etc. So, for the sake of simplicity, generally Unix and Linux are considered to be the same term. So, for our sake, also we will continue to use them accordingly. So, what are the perks of using a Linux system? So, Linux provides us with a complete access over the entire operating system. So, one has a full-fledged experience of the operating system as you can directly talk to the hardware or the system it utilizes. But whereas for other operating systems, they do not provide us users such privileges. It also is backed by a great peer support system consisting of developers and researchers that will help you to troubleshoot at any given point. Whereas for other operating systems, generally we go to a paid help desk support and we have to pay some price to get that support, right? And also the command line accessibility is encouraged when we are handling big data as we do in bioinformatics. And lastly, one can freely download any version of Linux and it is never a paid service, unlike say Windows operating system, because there are some licensing restrictions which follows in Windows operating system, right? So now, let us briefly see the advantages of Unix. So for example, Linux is installed in servers most of the time. So during working on bioinformatics analysis, we actually need to analyze the data, right? So most of the time, our organization under whom we are working presently provide us the access of the servers, which is simultaneously being used by various others who are also working under the same organization. Yet, the presence of numerous users simultaneously in the same time never caused the system to crash. Moreover, security breach also never happens as the particular user can only access their own data and the administrator do not generally allow them to access any other user's data. And lastly, we can deal with big data in bioinformatics, such as, say, genomics data or NGS data, and we can analyze them very much efficiently using the command line prompt, which we cannot do generally in Windows system, or we might sometimes can do, but it would take a huge amount of time to analyze the data. Okay. So coming to it, what is the unique Linux OS mainly boils down to using these four standard applications. As Sir have already told you in the last session, let me just brief once again. So number one, text editors. So one such example is gedit, whose application was already shown to you by Sir in the previous section, and it simply boils down to it that it allows a user to edit a text file. Second is compiler, mainly used by developers. So I'm not going into it in a details in this session because you guys will not need that in today's session. And number three, file system commands. It is the functionality of the terminal that allows us to utilize a huge amount of file system commands on Linux and compared to Windows or other OS. So I'm stressing on this portion that Linux the main perk of Linux using Linux operating system is having the utility of a command prompt. It is a huge beneficial for anyone who is in the bioinformatics field, as because we deal with a data which is like humongous data, right? So that command prompt accessibility is a huge perk for any bioinformatician. And lastly, text processing. As I said earlier, that Linux lets us quickly access huge tabular data or CSV files that can take a hideous amount of time in other operating systems. So that is also a very nice perk for using Linux system. So now let us concentrate and understand the right hand side figure. This is a very important figure which clearly shows us all the components of an Unix operating system. So here, please follow my arrow of the mouse. So here the hardware of the OS is present. So followed by the kernel, then the shell, and lastly application at the top of it, right? So let us take an example. Okay, so if we think about it, let us say we have graphics card, processors, or RAMs, which are generally like uh, regarded as hardwares. Okay, so and now we have to talk to this hardware to execute any form of analysis or any program, right, in any OS, say. So what we do, we now have to talk to this hardware to let us access the OS and do our analysis, right? So to do that, we actually have to push our task on the top of the chart. That is, we have to discuss this particular task with the applications, right? The applications which are present in the user interface, we have to talk with them. So, such as let us take an example. So, if we want to edit a particular text, say by via gedit, which is an application, it is a default of Linux OS. So, what we do, we will open the G app, okay, and we will then give some command of our desire, which we want to give to the gedit app, right? So what will the gedit app do now? The gedit app will then pass it down to the shell, which is actually the terminal that I have been referring to from the very beginning. And then that particular command is being passed to the kernel, which is the actual operating system, and it finally translates that given command to the hardware in binary informations, that is say zeros and ones, right? And which is like hardware components only understand binary informations. Okay, so the information that flowed from application from to the shell, then to the kernel is has finally reached the hardware. The work will be done there, or say the analysis will be done there, and we will get a result of our analysis. So as I was saying, that kernel provides a bridge between the hardware and the users. It is a software application that is central to the operating system. Okay, so then shell, the program between the user and the kernel that translates the command which are typed in the terminal. So as I was saying, the shell is the interface we see as in the terminal. The shell interface is the terminal to us as the users. And lastly, the application. The applications are the utility layers on the Unix system, which includes such as, say, word processors, graphics programs, database management programs, or say in today's session, as we see Blast, it is also an application, right? And various other commands. So you can consider them as applications. So, as I have been saying, that the shell or the terminal or bash is the most unique feature of Linux OS, as a shell script is the combination of all the commands that we generally run very often and is stored in a single script, which help us to run it again and again in a repetitive manner. So as here it is said that a shell script combines Linux commands in such a way as to perform a specific task. Say, like editing a text file is a very uh, task we always want to do, as we will always do as in any in any task. So keeping those specific commands in a stored format in a script is known as the shell script. So for a shell script can be many a thing, and a shell script is basically regarded as a text file with all the instruction that is needed to execute a particular application or a particular task. Okay. So now, so to do so, we need to know the command syntax, right? As Sir has already told you in the previous session when he was trying to go through all the very numerously used command syntax. So let me show you what is a typical command syntax of a new Linux operating system looks like. So as here it is in this section, it is written that we can see the first to define the program is being defined or which we want to run, then it is followed by an options and then by specific arguments. You will get a very better understanding of these syntax commands in the latest section today taken by Nirban, my fellow colleague. So here where we have written that program name is the name of the program you desire to run. Okay. So for example, again, let us take such as gedit. So we'll write gedit here in the program name, and options gives us how we want to use the gedit, and then we will follow it with arguments that which specific words we want to edit, or if we want to give it a specific separate tabs or say space, many other things which we want to use in our way, we will give that argument in that position. Okay, in that command syntax. So finally, these are the very much mostly used in syntax in Linux OS. Most of them were shown to you all by Sir in the previous session, and like you can go through this table for your future reference and for today's reference also in the later session. So here what I have done is I have categorized the syntax. I have given you the command, the syntax example, and a particular example is also given so that you can all understand what that command is doing, and a brief description is given here also. Okay, so follow through all these commands and you all will get a brief, like a very good idea about how the syntax works for us. So this is one table and followed by the another, like say for example in bioinformatics we use these commands like sam tools, fast qc. These are very much in use in bioinformatics. Okay, and you can say that qc, the description is also given, a particular example is also given so that you all can understand. So yeah, and you all will also understand this particular commands today for blast also. I'm not included that here because you all will get to know about it in the later session by Anirban. Okay, so now lastly, Linux operating system, what are the applications in bioinformatics, right? So first, it is very efficient, as I've been telling you that it is very efficient for handling big biological data. So as bioinformaticians, we are encouraged to use, and we only use Linux operating system. So number two is, as I've been stressing on, and I can't stress it enough, like the command line tool is a very powerful tool for any bioinformatician, and Linux let us do that thing in a very swift manner. Okay, so that is a very good application in of Linux system in bioinformatics. And lastly, the script shell, that is that I have been talking about, that it makes automation very easy. Like using Linux operating system, automation can be done very easily. And for handling big data in biology, we need some kind of automation, because we always do a very repetitive kind of work to understand the biological data, right? So to write it from the very beginning is a very tedious work for us. So to automate it is a very logical thing to do, and it's a very clever way to do our thing, right? So it Linux give us that perk to use it. And now for this will be all for the brief overview of the system which we are using, that is Linux operating system. And now Anirban will show you such application, say, that is running Blast in Linux OS. And so from here on, it is over to you, Anirban.
Yeah, good afternoon, everyone. I am Anirban Nandi, and today I will be demonstrating a bit of how to install NCBI Blast using Linux system. Okay, so I hope that you have been a bit familiar with the comments. So now time for the practical application, right? So I'll be sharing my screen. Okay, so to install NCBI Blast, just open your browser, type download NCBI Blast. Okay, press enter. See, here are all the links being provided. Now click on the very first link. Okay, Blast Plus executables. After clicking on this, see, this type of interface will open. Now, what are the next steps? In this section, we'll click on this link, that is FTP link. See, https ftp.ncbi.nlm. We'll click on this link. After clicking, this parent directory will open for all the type of operating system that we have. Coming down, we see this one, NCBI Blast 2.616.0. Now, uh, is my voice echoing? Any problem? Or is it breaking? Okay. So, yeah. So after coming into this page, we just see, we will just find here that it is Linux star GZ1 and another is Linux star GZ MD5. Now, what is the basic difference? Like, why we are choosing the above one and not the below one? Because both are in Linux system, right? And see, we can find that the other side in macOS, Windows 64 bits, all these stuffs. So why we are choosing only the above Linux star GZ? This is because uh, the Linux star GZ, it is the main file, and it is a like compressed archive containing the Blast Plus binaries for the 62-bit Linux, which is this operating system. And this MD5, it is the checksum file, means it contains the MD5 hash of the tar GZ file, like which is in simple terms, it is used to verify the integrity of the downloadable file. So one format you can one way you can download this is just by clicking here. You can click here and you can see here it is being downloaded. But in Linux system, we'd love to use the terminal system, right? So just select this whole link, rgz, right click it, copy link, not copy. We have to click on this copy link, right? Copy link and keep it. Open a terminal. Yeah, make it, let us make it full screen. Yeah. So in the previous session, uh, I think you have mentioned that the comments CD, yeah, CD means change directory. We'll love to keep it in our download section. So for that, we are from our, it is, you can see that it is in our workstation, means it is in the system. From there, we are changing our directory to downloads. To CD, change directory, we'll type downloads. Okay, let me explain a bit better. See, it is in the system. In the system, we have got files. Similarly, in Windows also, we have got downloads. See, here we want to download it, right? We want to keep it. So for that, CD downloads. Downloads. It has, see, now this dollar sign will appear. It means that the program name, and later we'll deal with the options, means the change the behavior of the program. Later we'll deal with that also. So in the download section, we'll we have open terminal, like from CD, the change of directory to the downloads. Now what we'll be doing that, we'll type ls, means list. See, these are the components in our download section. Another thing we can do here is ls space dash, means this dash in Linux means options, which is used to change the behavior of the program. See, this is also ls, and the previous one, this command is also ls. The difference is that is created by this hyphen or the option. And now we type, uh, oh, sorry, oh, ls space ltrh, oh, ltrh. Okay, this means it will show us the long list, where L means the long listing format, showing the detailed file input or the information. The T means the modification time. It will sort by the newest one first, and the R means the reverses the order so that the oldest files appears the last, and the human readable file sizes, LTRH. Okay, so now we'll be downloading this one, WGET, which means we want to download it from any URL. From URL, we have just copied it. So now we'll be pasting that URL. See, this URL is this URL, right? This Linux, let me open it. Yeah, this is the link. We have copied it right here. HTTP ncpi dot. Press enter. And yeah, you'll see it's been connected and it is being downloaded. It's been connected and it's been downloaded. It will like take like 1.5 minutes to download it. So see, the downloaded format is in tar gz. In the previous session, you have mentioned that tar means that it is in, if you say in Windows format, it is in zip format, right? We have to unzip it, or we have to extract the contents from this file. So let us let it download. After downloading, yeah, see, it has been downloaded. How can you understand that it has been downloaded? We can see the cursor blinking here in the next line. Once again, ls list. Yeah, see here in this arena, in this arena, this one was absent. NCBI blast was absent, right? Now we can see that it is being downloaded here. So it is appeared. It has appeared here, NCBI blast. So now we'll be doing we'll be copying this one now. Copy like tar xvzf. Now this comments refers to unzipping of this folder. Okay. In Windows format, we can say that we are simply extracting the contents from this folder. From which folder? This NCBI blast. Okay, just paste it. After pasting it, press enter. See, it is being all the files are being unzipped. Yeah, after unzipping, once again ls the list. See, here you can see that NCBI another folder has been added. This one was previously present NCBI Blast 2.616.0 here also, but this one has been added newly NCBI Blast 2.616.0. Okay, now we will change our directory to this because this is the main working directory which will be performing the blast function. So cd, simply copy it, paste it, and enter. See, if we take it, summarize from the very first section, it will be like we are into the workstation, then we have moved on to our downloads, then we have changed our directory finally to NCBI Blast, this one. And the dollar sign, as I mentioned, it is like the program name. Okay. So now we'll be like, we have changed our directory to NCBI Blast. Now, once again, type ls. So this. Here are the list of the things will deal with this folder. The most important is this bin. It contains all the binary information. As in the previous presentation, Srikanth, you have mentioned that about you have seen that diagrammatic overview that hardware, kernel, shell, and finally application. So running this application, that is the blast, we require this hardware. Now, where this hardware lies? It lies within the bin because it understands only the binaries, the components. Okay. So into the bin, we'll be changing our directory cd bin. So what we are gone to from workstation to downloads to NCBI Blast and ultimately into our bin. Okay. And if we want to see the long list, ls hyphen ltrh, enter. So this is the long list. You can see that it is all within the bin. See, you can see the blast n, blast p, blast x will be running blast p. Okay. So what we'll be doing next is that dot slash. It means current directory. Okay. Blast p space hyphen h. So what we have done from workstation, we have gone into downloads into NCBI Blast to our bin where all the binary components are present. And from bin, upon selecting the long list, we have got all these types of list within the bin package. Now from the bin, we are this one dot slash means the current directory is active, which is the bin component. It is the latest directory. So it is the current directory we are addressing to. And ultimately we are performing blast p. This H means the help section. So let us press enter. Yeah. So yeah. So it is running absolutely okay, right? So probably we are running out of time now. So in the very next session, we'll be performing how to download a protein sequence, which will be in the FASTA format, and we'll be performing the blast. So for today's session, we have what we have done is that just a quick summary. So if we type clear, yeah, you see all the previous comments have been cleared, and we are still in the bin section. So what we have done today is that just a brief overview of all the comments and the all the comments in the Linux interface, and ultimately we have downloaded the blast, that is the application in the Linux interface. Okay, so next day we'll be downloading our protein of interest. We'll be downloading all the FASTA format of it, and ultimately we'll be running blast in this Linux server. Okay, and ultimately do the analysis in Linux system. Okay.